Good morning, this is your Stat Sensei, Mr. Spensei, and this is an exit ticket on confidence interval. We're going to do both a paired and a one sample. So at a high school of over 1,000, this sounds like this over 3,000, excuse me. This sounds like the population size right here. Good to know. 10 students were randomly selected. All right. So here's my sample size of 10. Good to know that it was randomly selected because that's my first condition. That's condition one. To participate in the study to test whether using their phone before bed affects their sleep quality. Each participant tracks their sleep score out of 100 for 2 nights, one where they use their phone for an hour before bed and another where they are avoided screens for an hour before bed. Avoided screens for an hour before bed. So no phone night. The participants were randomly assigned as to which night that they were used to use their phone prior to going to sleep and which night they would not use their phone. Oh, so this is random assignment. This is good. Um, the results are found in the table below, and the dot plot indicated the differences are normally distributed. That's our condition number three. All right, so each participant was tested twice, one with a phone night and one without a phone. Because they were tested twice, because each contestant person was tested twice, that makes this a paired. It says construct a 95% confidence interval for the difference in average sleep, no phone night minus phone night. So no phone minus phone. All right. Make sure we have that because this means it's going to be L2 minus L1. So my formula or my equation is x bar d plus or minus t star s d divided by square root of n. I know this looks like a one sample T, but one sample T does not have the D's. And if you don't have the D's, it's not right because this is paired. All right. So I took the time and I've entered all that data into the calculator. And there it is in L1 and L2. Now it specifically said no phone night minus phone night. Really important to notice this because we're going to go L2 minus L1. If you go in a different order, you will ultimately end up with the right answer, but your signs will be different than everybody else's. So L2, blue 2, oop, there we go, L2 minus blue 1. So this is why I have negative values because I went opposite of the order that was given. You know what? That is the wrong data. Sorry about that. Wrong calculator. Here we go. There's the data entered in the blue one and all right, 72, 68, etc. And I need to go blue 2 minus blue 1. And there's my differences. All right. And 78 minus 72 is 6. So there they are. Stat calc, 1 var stats, blue 3, because that's where my differences are. And I end up with a sample mean of 5.8. We know we have 10 pairs of data. My sample standard deviation is 0.6324. And degrees of freedom, please remember, is n minus 1 or 10 minus 1. All right. One sampled paired t interval is what we're going to run. Please remember to include the word paired. All right. One sample paired t interval, and you've got to include the word paired because if you're having something measured twice, it's paired data. All right. So to calculate our t star, to do that, we're going to have to go second vars, inverse t, parenthesis, 1 minus. We want a 95%, 1 minus 0.95, close parenthesis divided by 2. Degrees of freedom is sample size minus 1, so 10 minus 1. And we end up getting 2.2621 and we're always going to make these positive. So make sure that's a positive. All right. Plugging in. Here's my X bar D. This is my T star. This is my SD. And this is my N. Remember? And that's where they came from. 5.8 X bar D. T star right here. SD right here. And sample size right there. To go ahead and run this to get the interval, stat, test, drop down to number 8, which is just a plain old T interval. And we have to plug in. Oh, I grabbed the wrong calculator again. Sorry about that. Stat, make sure I have the right one. Yeah, I do. Stat, test, number 8, T interval. We have data. The list that we're interested in is an L3, so blue 3. And we want run a 95%. So we end up getting 5.34 to 6.25. So basically they're saying, hey, no phone is 5 to 6 points better sleep per night. So this is my lower bound, and this is my upper bound. All right. Okay. So that was the paired. Now we're going to just run a plain old one sample T interval, not paired data. It says more than 1 million young people snack at night. Well, that to me sounds like a population. So this sounds like my population right here. And it's estimated that they consume more, an average of 400 calories when they snack. So this is my pop. This right here gives me a mean, population mean of 400. A nutritionist believes they consume more calories. A survey of 110, okay. And by the way, this is more, that's interesting. Survey of 110. Oops. So N is 110. Finds an average of 420. So we have an X bar of 420 and an S of 90. So X bar is 420, S is 90, a sample standard deviation of 90. Construct a 92% interval. All right. So our formula, X bar plus or minus T star, S divided by square root of N. There was no testing of twice. There was no testing twice. There was no before and after. This is not paired. This is just a plain old one sample. Make sure you run it as a one sample, not as a paired. All right. So the X bar is 420 calories. Please remember, we used X bar, not the population. This is the population claim. We used the sample mean because that's what they asked for, the sample mean. And the sample standard deviation is 90. Our sample size is 110. And then we're going to go 110 minus 1 because remember, it's N minus 1 is our degrees of freedom. So 110 minus 1 or 109. We need to calculate our T star. To do that, we're going to go second vars, inverse T, parenthesis 1 minus 0.92, because they wanted a 92%, divided by 2. And our degrees of freedom is 110 minus 1. And we end up getting 1.76, which is what we have here. Make sure it's always positive. Well, now we can plug in. All right, so plugging in. X bar is 420. T star, we calculated it right here. Our sample standard deviation is our SX. And this is in our sample size. All right, we are running a one sample T interval for means. Make sure you do not say the word paired because it's not paired. If you do, it's incorrect. All right, and will be counted as such. And now we're going to run this test. So stat, test, drop down to number 8, which is T interval. And we have a sample mean. Oh, make sure stats is highlighted. We have a sample mean of 420. We have a sample standard deviation of 90. We have a sample size of 110, and we're going to do a 92%. So 404 to 435. So we're saying, hey, it looks like the claim of 400 does not seem reasonable because it's not in the interval. It looks like they consume somewhere between 404 to 435 calories when they snack at night. With an average, this is our best guess is 420, but it could be as low as 404 or as high as 435. All right, appreciate you watching. Look forward to seeing you on the next one. Thank you.